Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Al-Wazamani. My matric number E8E190027. So I from group number 4, and the title of my group is Solar Inverter. Okay. For the introduction, power electronic is essential for integrating current technologies to the utility grids every day. Renewable energy sources, photovoltaic array, and wind turbine transform renewable energy source like solar photovoltaic and wind into direct current or DC. So, in order to use the renewable energy mentioned above, an inverter is required, which turn DC into AC at the system frequency. Okay, PMW, which is pulse width modulation, is a technique for producing switch voltage pulses in which the amplitude, phase, and frequency of the voltage are all controlled. Isolated gate power bipolar transistor IGBT switch are used in the inverter, which can handle a lot of current and voltage. Because of its simplicity and durable control method, the PMW inverter has been the standard in power electronics for decades. Okay, the proposed research project entailed the development of a single-phase SPMW inverter that would convert DC electricity from solar panel into AC power for low-cost residential application.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. So this is our circuit for the solar inverter in here. So before the solar inverter, the input is the solar panel, and then to the DC converter, and after the solar inverter in here. So first, the input for the solar panel is a 1000 radius and 25 degrees Celsius for temperature, and this type of solar panel is SolarTech S72MC190, and the maximum voltage is the 36.66, and this is a plot for the input for the current power for the solar panel. And then want to see the output. For the output, the DC converter is a 339 volt. This is also the input for the inverter, and this is a graph for the this is input for the DC, and this output current, and this output voltage for the DC converter. And then what you want to see, this the solar inverter in here. We have the PWM generator in here in the unipolar form. This is a graph for the unipolar wave in here. And then we have also two types of simulation in here. This filter in parallel circuit, which is used by LC in here. Before that, we want to see the without first. So for the without the filter, there's only the flood in here. Without the filter, the output like this. The output will be like this. So the wave is not much better without the filter in here. The wave is like square, but we want to see the S wave in here. That's what we want. So if we want that, we use the filter in here. We have for the value for the impedance, L is the 5.893 times the 10 power of negative 3, and for the capacitance 66.494 times the 10 power of negative 6, and it still use 10 ohms in here. Yes, this output voltage and output current in here, what you want to see. So the wave is nice and better than before. The S like this. Okay, the max min in here, we can see the max for the voltage is a value 283.6, and the min is 283.7, negative value in here, and the RMS value is 166.4 volt for the RMS, and current 28.36 for the max, and min the 28.37, and negative value in here, and RMS 16.64 for the test for the RMS value. So next, what you want to see, THD value, total harmonic distortion. We click this, and also click the FFT analysis. But I will click it, it should be like this. So first, input 1 is the voltage output, 50 Hz we use, and max voltage is 10,000 Hz. We compute it, we get like this, 34.13% for the total harmonic distortion, and the fundamental is 19.85. And for the current, we compute it, 1.985 for the fundamental, and THD is 34.13%, like same before. So what we want to see is THD is below 5%. This value is very high for me. So if you want to decrease the THD, you must see first the cause, the effect. So the cause is this wave for the first 0.12 or 0.14, it is increasing voltage in here, which is for the increasing voltage for the battery or source for the inverter. So the stable wave is start from here, like here. The time is 0.14 second. That is that time the wave is more stable. But as you wait, I will start the time is 0.1, 0.2. So that's the start time for the we calculate the THD. That is more stable wave. So like I said, the THD will decrease 0.99%. That's what we want, below the 5%. This for the current, and also the voltage also same. Also I think 0.1, 0.2 seconds start, and THD value is 0.99%, and fundamental is 280.7. Fundamental also increase for here. So that's all for the simulation. Next.
Yeah, Assalamualaikum. And now I'm going to present about the calculation analysis. So as you can see here, this represent the value of the component in our circuit. So we have the VDC, resistance, frequency, inductance, and the capacitance. So first we find the omega. After that, we find the SL and SC for calculating the impedance in the next step. Then after get the value here. So for the ZR is equal to R, which is 10 ohm, while ZLC is parallel to each other. So by substitute the value here. And then after that, ZRLC, we need to plus 10 because it is series with ZLC. So this is the final part for ZRLC. And then we need to input this N here, which is equal to 1, 3, and 5 into this to get the impedance value. So this is all the impedance value that we get. And next is to find the degree. This is the same by using this equation. Substitutes this N here and then get the value. And next, to find the THD for the voltage part, we calculate by set 2 here and then get this voltage. And then substitute into the output voltage equation here. And then for the VP, we insert all the value given here in this equation. And then we get this value is equal to 514.36. And then substitute into this equation to get the THD percentage by plus the first VM. And then got the equation is equal to 0.38, which is 38%. Same for the current. For the current THD, repeat the same step, but this time you need to divide this by equal to the impedance value for every part. And then we got the value, calculate like the step before, and then we get the THD is equal to 0.33%. So equal to 33%. And then for the power absorbed by the load, we using the IRMS and then put into this equation using the R load, and then we got the value is equal to 129.67.2 watt. So this is the difference between simulation and calculation THD percentage. So as you can see, for the THD current, the simulation is 34.4 and for the calculation is 34, which is not too far. While the THD voltage is 34.4 and for the calculation value that we got is equal to 38, which is a little bit far, but that's okay, I think. So that's all for me. Thank you.
So as for the discussion, DC-DC converters, which is what we use mainly in this assignment, DC-DC converter and DC to AC inverter. So DC-DC converters can change a fixed DC input voltage into a variable DC voltage or the other way. The duty cycle is used to control the DC output voltage, while an AC-DC converter is a device that can change AC voltage into DC voltage. The DC voltage output can be controlled by changing the firing angle. Next, for the filter. An input filter is necessary because it prevents noise from being reflected back onto the mains power supply from the power supply switching elements. It also keeps noise from getting into subsequent circuits from the mains power supply. So as you can see here, the difference between output of inverter without filter and with filter. So the wave with filter is much more better than the wave without the filter. So next, as for the calculation, we use two formula, which is fast Fourier transform and total harmonic distortion. Fast Fourier transform breaks down a signal into individual spectral components and thus provides frequency information. The total harmonic distortion, one way to assess the quality of a power supply. So as you can see here, what we use for the formula total harmonic distortion.
Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Muhammad Hafiz bin Zulkifli with metric ID 8E190016. So next I will present about the last part of the project, which is conclusion. First one is photovoltaic power generation is becoming more popular as a renewable energy source due to its multiple benefits, which is pollution-free energy production, ease maintenance, direct solar to electricity conversion. The next point is the disadvantage of the PV installation, which is the high cost of PV installation is always being a barrier to technology adoption. Furthermore, PV panel output power is affected by weather. So if the weather is not has a high level of isolation and the cell temperature is low, so it's more than not work. So for the next point is PV system integrated into national network can minimize transmission and distribution line loss, improve resilient power production costs, and reduce the need for the new utilities generation capacities. Next point is majorities of the research of the integration has a good result for the impact of this integration on system stability and security should be truly considered. And the last point is innovative integration technology should be studied before plant is deployed. So the generation and distribution company will be able to predict the impact of the PV integration and generation on the system stability and as an outcome of this. So that's all for this project for power electronic. Thank you.